Hi. So we're going to continue on with lesson number 2 now in chapter 10, and this is going to be on vertex form and completing the square. So let me just tell you, in chapter 10, you're going to have to solve quadratics using any one of 3 different methods. So we just covered the first one, believe it or not, we're 1/3 of the way done with solving quadratics because the method of factoring is the first and always the default method you should refer to when you're solving quadratics. This second method is a little less common, but you are definitely going to see it. But this is called completing the square. So we're going to be talking about today vertex form and completing the square. Now, if we're looking at page number 254 in your workbook, you're going to see that lesson 2 says in algebra, you will use an algebraic method known as completing the square. By completing the square, you can find the zeros of the parabola and also place the equation in vertex form. Today, you will practice placing equations in vertex form in order to find the vertex of a parabola. Now, a quadratic equation is in vertex form when it is in the form y equals a times x minus h squared plus k, where h comma k is the vertex of the parabola. So let's just take a look at this equation right here that's in vertex form, and we're going to take a look at this h value, this k value, and this a value. Now, all of these values can change, and when they change, they affect the graph of your quadratic. So right now, we're going to take a look at what this equation looks like in our Desmos calculator. So I'm going to pull it up right over here, and you can see it now. And what you're going to see is y equals a times x minus h squared plus k. And they're all equal to 1 right now. So we're going to just take this slider, we're going to drag it. So let's see what it looks like if a is greater than 1. Oh, that makes the parabola narrower. And let's see if it's a number that's between 0 and 1. Ooh, that thing's going to make it wider. So we know this all from chapter 6. Oh, now my a value is 0, which makes it a straight line, because remember, that we can't have an a value of 0 when we have a quadratic equation. B and C can be 0, but not a. Now, if it's negative, it flips it upside down. So all of your possibilities of your a values do have an effect on it. Notice one thing, and only one thing, that's not changing about this parabola. What's the one thing that stays constant throughout the entire thing? And yes, if you were thinking that it was the vertex, you're correct. So let me play this again and take a look at that. Your vertex is not changing. It's stuck. It's staying there at 1, 1. And if you want to know where that 1, 1 comes from at the vertex, why don't you look at h and k, what they're equal to over here. So h is equal to 1 and k is equal to 1. But let's see what happens if we make k equal to 2. Now, where's our vertex now? Our vertex is at 1, 2. And again, that number outside doesn't affect the vertex. It only affects how wide or narrow it is. Now, if I take that h and I make that h maybe like a 5, let's make it 5, you'll see that our vertex is now at 5, 2. When h is 5 and k is 2, your vertex is 5, 2. And this should all make sense with your shifting rules as well, because what you're really doing, if h equals positive 5, and your formula says to subtract h, you're subtracting 5 inside, which moves your parabola right, and you're adding 2 on the outside, which moves your parabola up, which means if you were to subtract 2 or add a negative, then yes, your parabola is going to move down. And adding higher numbers will move it up. And if we have a negative h value, it's going to move it to the left. Okay? So now we've seen the a value does. The a value makes that parabola wider, narrower, or flipped. The h value will move it left or right, depending on its value. and the k value will move it up or down, depending on if it's positive or negative.